Okay, let's do some problems. To find global extrema, we are going to follow this step-by-step process. First, we're going to find the critical points. All right, so we're finding the critical points. That's when the derivative equals 0 or is undefined. So we need to find the derivative. 3x squared minus 6x minus 9. And we want that equal to 0 or undefined. So this is always defined, right? This is a parabola. So the only critical point will be when this derivative equals 0. And now we'll just factor this so we can solve. We can take out a greatest common factor of 3. And now we need two numbers that multiply to negative 3 that add to positive 2. That add to negative 2. We'll get x minus 3 and x plus 1. So we're going to have a critical point when x is equal to negative 1 and when x is equal to positive 3. Both of which are in our domain. That's very important. Okay, this problem is specifically saying only look at this cubic function on this domain. So this is our domain right here. That was step 1, was find the critical point. Oh, we need the y values for critical points. The critical points are negative 1 comma something and 3 comma something. We need their y values. F prime gives us the slope. F gives us the y values. So what is f of negative 1? We get negative 1. I shouldn't do this in my head. Go back to our calculator. Yeah, plug in negative 1. This is a different function. We get negative 1 cubed minus 3 times negative 1 squared minus 9 times negative 1 plus 5. And we're going to get 10. And when we plug in 3 instead, we're going to get negative 22. So now we have our critical points. So this isn't our answer, but it's very important. So I'm not going to box it because it's not my answer, but I do want to bring attention to it somehow so I can see this for later. That was step 1, was finding the critical points. Because the only options for global extrema are critical points and endpoints. So now we need to look at the y values at the endpoints. That's step 2. All right, y values at endpoints. Well, one endpoint is at negative 2. The other endpoint is at 6. Let's just find out the function value at those 2 points. At 6, it's 59. At negative 2, it's 3. Great. Now all step 3 is look at all of our y values and pick the biggest and the smallest. That's it. Pick the biggest and the smallest y values. That'll give us our answer. So the global max is 59. That's the biggest number. And it occurs when x is 6 on the end of our interval. The global min, what was the smallest number? Not 3, actually 22. The smallest this function gets on this interval is negative 22. which is when x equals 3. That's our global extrema, and that's how the best way to phrase our answer. There we go. Let's check it. All right, let's graph this. Y equals x cubed minus 3x squared minus 9x plus 5. I'm going to use the squiggly braces to put the domain, -2, less than or equal to x, less than or equal to 6. We need to see a little higher. Yeah, this is the function on the interval. The global minimum is that -22 when x is 3. What's the biggest the function ever gets? It's on the right endpoint. Biggest it ever gets is 59 when x is 6. Just like we said. That's what it looks like, and we did it by hand. All the magic. We did it without even seeing what it looked like. The power of calculus. All right. Last example. I think of the whole section. Oh, we got some homework problems after this. Okay, so this one didn't specify the domain. So that means our domain is all real numbers. All right, the domain is all real numbers. So this will be a little trickier, but it's the same idea. First, we're going to find the critical points. Well, the derivative, we just use the power rule again. Critical points are where the derivative equals 0 or doesn't exist. Well, this always exists, so let's just set it equal to 0. And just like before, we'll factor. We're left with an x squared minus a 1, and we can factor again. X minus 1, x plus 1. The critical points are when x is 0, because if x is 0, this whole term is 0. When x is 1, from this term, and when x is -1. 3 critical points. Let's find and actually write them as points. -1 comma something, 0 comma something, and 1 comma something. These are our critical points. You plug in -1. I can surely do this one in my head. We get +1. -2 is -1. We get 3. Plug in 1, you get the same thing. 1 minus 2 is -1, plus 4 is 3. And then when you plug in 0, you get +4. These are going to be important. Now remember, step 2 was to check the y values at the endpoints. But we don't have endpoints. We have to look at the long run behavior of this function. This is a 4th degree polynomial. The degree is 4. Again, there are no endpoints here, so we're going to say long run behavior. No endpoints here. The degree is 4, which is even. So we know the long run behavior either has to go to positive infinity on both sides or to negative infinity on both sides. To do that, remember that we have to look at the leading coefficient. You have to remember back to your pre-calc days for this. The leading coefficient is positive. It's 1. So that tells us the long run behavior is on the left, it shoots off to infinity. And on the right, it shoots off to infinity. So what does this tell us about global extremum? Well, this function gets infinitely big. There is no global maximum. Right? This gets infinitely big. But it doesn't get infinitely small, so there still can be a global minimum. What are our candidates here? These are our 3 candidates. Which one's the smallest? Both of these. So how do you write that? We're going to say global min of 3, right? The global minimum is the y value. So it doesn't matter if there's 2 y values, we still write that the same. When does that happen? When x is either positive or -1. Let's graph it and check our answer. X to the 4th minus 2x squared plus 4. Global minimum is 3 when x is positive or -1. And just like we said, this function has no global maximum. It will go up and up and up and up and up forever. There is no biggest number for this function. This function to the moon and then keeps going. All right. That's what we've got. Got a couple homework problems for you coming up in the next video. If you want to get into some of them, start them. And then if you're curious about what they look like, or if you just want more practice, you can check out that video. Adios.